An open box, that's a box without a top, is to be made from a rectangular sheet of card measuring 16 centimeters by 10 centimeters. 4 equal squares are to be cut from each corner and the flaps folded up. Find the length of a side of a square which makes the volume of the box as large as possible and find the maximum volume. So if this is our rectangular sheet of card and it's 16 centimeters by 10 centimeters, what we're doing is cutting a square from each corner like so, and then we're going to fold up those flaps to produce a box. Now it doesn't have a lid, but it does have a bottom. So if I say that this is X, and then these are all squares and they're all identical, so all of these are X, that means that this length here would be 10 minus 2x, and this length here would be 16 minus 2x. And that means that when we fold up our box, we get a side here that's 16 minus 2x. This would be 10 minus 2x. And clearly, when you fold up, the height is going to be x. And that means that the volume of the box is going to be x times 10 minus 2x times 16 minus 2x. So V is going to be x into 160, take away 32x, take away 20x plus 4x squared. So that's going to be 160x. These two together make 52, so that's going to be take away 52x squared plus 4x cubed. So we've got dv dx as 160, take away 104x plus 12x squared. Now we're interested in dv dx equals 0, which means that 12x squared take away 104x plus 160 is equal to 0. We can certainly divide all of that by 4. So I've got 3x squared take away 26x plus 40 is equal to 0. So with 3 being prime, we have to have 3x and x. I'm presuming at the moment that it factorizes. If not, we would have to use the formula or solve it on the class pad or something. Now, I think what would probably work here is if I go for negative 20 here and negative 2 here. So we've got x is equal to 2 or x is equal to 20 divided by 3. This one is actually not possible. 20 divided by 3 is more than 6, and that means here we would end up with a negative length. So only the 2 can be a solution here. So we have that x is equal to 2 centimeters. That's the length of our flap. And then the volume is going to be 160 times 2, take away 52 times 2 squared, plus 4 times 2 cubed. So we can calculate that. So 160 times 2, take away 52 times 4, add 4 times 8, gives us 144 cubic centimeters. And we could go ahead and do a second derivative or some other test to show that it is a maximum, but we're not required to do that.